Okay, 8.2. Now we're talking about adding and subtracting rational expressions. And so the stuff from simplifying still applies. We just have to do some steps that are different when we add or subtract. Namely, when you add or subtract fractions, to combine them, it requires a common denominator. For example, 4 over 5 plus 3 over 5, they have a common denominator, which means you can combine these fractions. And how do you do it? Well, you just add the tops, right? You add the numerators. 4 plus 3 is 7 over 5. Well, we got two types of problems we're going to focus on. Problems that already have like denominators. That's what we'll start with. And then problems that do not have common denominators. And so first, if they already have like denominators, well, all you need to do is just add or subtract the tops, add or subtract the numerators. Then you need to factor and cancel like factors to simplify. All of these problems should be simplified at the end once you've done the operation. So here, look at this first example. Notice they both have the same denominator, which means we can combine these by just adding the numerators. And so we've got 13a plus 5a. Now, don't make the mistake here that a lot of people make. Because it's in a different context, they kind of like forget how to add terms like this. Well, when you add terms like that, you don't get an a squared, right? 13 plus 5 is 18, so you get 18a. Now, notice they have the same denominator, right? So you just combine the tops over the same denominator. And now, once we're in this one fraction form, now we can simplify like we were doing before. And so 2 goes into 18 9 times, 2 goes into 4 2 times, so we have 9 over 2. This one a cancels with one of those a's, but we still have an a left over in the bottom, and that's your answer. Take a look at this next example. They do have common denominators. Now with this one, we are subtracting. So be careful when you are subtracting. We need to subtract this expression, or we need to subtract this expression from that one, which means we need to distribute this negative. So I just copied this down, 9x plus 12. Distribute the negative. A lot of people make this mistake. You have to distribute it to both of these terms. So now we have minus 7x and minus 2, all over the same denominator, 16. So now we can combine like terms. 9x minus 7x is 2x. 12 minus 2 is 10, all over 16. I factored out a 2 and canceled. Or when you have a scenario like this, you can divide every one of the coefficients by their common factor. So we can divide by 2, right? This would be 1, this would be 8, and that's your final answer. Make sure you distribute the negative. Take a look at this example. They do have common denominators. Now first you have to look, do they have common denominators? Since they do, we can subtract just the numerators. So that's 1 minus 16a squared. Now this is the difference of squares. Usually you see it with this term first, but this is still difference of squares. And this thing here factors into 1 plus 4a times 1 minus 4a. And then I factored this. Now notice, I didn't factor it first. First you need to combine. First you need to add or subtract the fractions, then you need to factor. And so I factored this, difference of squares, and then I factored a 3 out of this, so I got 4a minus 1. Now, notice, 1 minus 4a, 4a minus 1. These cancel into negative 1, if you remember from yesterday. And so I need to distribute my negative 1 to the top here, to this binomial. Distribute. So negative 1 minus 4a all over 3, and that's your final answer. Next, we'll talk about, well, how do you find a common denominator if they don't have one? And for this next example, notice they do have common denominators, right? So since they have common denominators, I'm going to subtract 16a squared from 1. I combine them on the same line. Now I can factor. Notice this is the difference of squares. It might be different from what you're used to. Usually the 16a squared would be first, but this still works the same. This is a perfect square. this term is a perfect square. And so it factors into 1 plus 4a times 1 minus 4a, right? Now, I also need to factor the denominator. Now notice, you don't factor anything first. You have to add or subtract your fractions first, then you factor. And so this guy here, he has a common factor of 3. I factored it out. I get 4a minus 1. Now, this here is 1 minus 4a, and this is 4a minus 1. Notice how they're flip-flopped, and there's both negatives there. This actually cancels into negative 1, if you remember from yesterday. And so we have this binomial times negative 1, so I have to distribute that. So I get negative 1 minus 4a all over what's left here is 3. And that's your answer, simplified. All right, so next let's talk about unlike denominators. So, if your rational expressions do not have like denominators, first, you're going to need to find the least common denominator. The LCD, least common denominator. From here on, I'm just calling it LCD. Now, let's talk finding LCD. Now, we call it the least common denominator because there are denominators that are bigger that will still work. But it'll make your work harder. So finding the least common one will just make your work easier. So, when you're finding the LCD, first you just want to look at the expressions in the bottom of the fraction. So, let's take a look at 3 examples. Let's just say these are the expressions in the bottoms of 2 fractions, okay? So take a look at 2x and 3x. For us to find the common denominator, we want to look at the factors. Now factors are something times something, right? So it's got a factor of 2, a factor of x. This other one has a factor of 3, a factor of x. Notice, they both have an x in common. So, our LCD is going to have an x in common. Now we don't have to repeat this x. In our LCD, this one x here is going to cover the x from each of the terms. Next, this one has a factor of 2. This one has a factor of 3. So our LCD is a combination of all of the factors involved. And so it's a 2 times 3 times x. The x was in each one, so we didn't need 2 x's there. I hope you know what I'm saying. So our LCD is 2 times 3 times x. 2 times 3 is 6. So 6x is our LCD. Take a look. That means that 2x, it does go into 6x. How many times? 3 times. Take a look at 3x. It does go into 6x. How many times? 2 times. That's what it means for this to be a common denominator. Now, this is the smallest one. There's bigger ones. For example, 12x. How about that? Yeah. 2x goes into 12x, 3x goes into 12x, but this one is the smallest one that they have in common. All right, so next, let's look at this next example. A squared and 8a. Now, it helps to break up your terms into factored form. So a squared in factored form is just a times a. So this thing here has 2 factors, an a and an a. This one also has an a, so they have an a in common. So we need the common a. All right, here it is. Now this one has another a. This one doesn't, but our least common denominator needs a combination of all factors. So since this one has 2 a's, the least common denominator has to have 2 a's. So we've got this a for the common one. This a here is the factor from this first thing, and then there's a factor of 8. Put them together, the least common denominator is 8a squared. Look at this one. Now it helps to first factor these. Now notice, these were monomials, so you didn't really have to factor much. These are binomials, so with this one here, we can factor out of 5, and we get k minus 2. Now it's a lot easier for us to see that, oh, this has a factor of k minus 2, this has a factor of k minus 2. Which means that our LCD needs to have a factor of k minus 2. There it is. That k minus 2 covers both of these. But this one has a factor of 5. And so we need to include that factor in our LCD. And so our least common denominator is 5 times k minus 2. Just leave your least common denominator in factored form. It will reduce your work at the end. Then you won't have to, because at the end you got to factor everything and cancel, but you don't want to do that until you add or subtract. I'll show you what I mean. Let's take a look then at the steps to solving when they don't have common denominators. Okay. So first, we'll want to factor the bottoms only. And that's so that we can find the least common denominator. Factor the bottoms only, find your LCD. Then you need to rewrite your fractions with the common denominator. I'll show you what I mean. At 4, you add or subtract the tops, you combine your fractions into 1, and then 5, you got to factor everything, factor the top completely, factor the bottom completely, and simplify. Take a look at this example. Now, factor bottoms only. So these, they're kind of already in factored form. I'm just going to separate this a squared into a times a. Now, we've looked at this already, right? So this one has, they both have an a in common. So our LCD has to have an a, right? But this has another factor of an a, okay? So we need to include that. And this one has a factor of 8, so we need to include that. So our LCD is 8a squared. Now, we need to get both denominators to this to become this common denominator, right? And so what is this one missing from the LCD? It's missing the 8, right? Which means we need to multiply the bottom here by 8. And we have to do that to the top as well because it's a fraction, right? So this is step 3, rewrite with common denominator. This is the process of rewriting these fractions to have a common denominator. So I needed to multiply this one by 8 because my LCD is 8a squared. And what's this one missing? This one is 8a, this one's 8a squared, so it's missing another a, right? So I need to multiply both top and bottom by a. So once you do the process, the bottoms should have a common denominator. And so your common denominator is your LCD. And so when you combine the tops, you can just use the LCD because you've taken both of these fractions, transformed them so that they have the same denominator. So now what's left is for me to multiply 8 times 4a, multiply 7 times a, and then subtract. Well, 8 times 4a is 32a. And then when I subtract 7a, here it is. Now I need to combine like terms. And so these are like terms, right? Okay, 32 minus 7 is 25. So this becomes 25a. Notice I still have my LCD here, common denominator. Now I could cancel any common factors. And you can't cancel your common factors till the very end because first you need to add or subtract the tops. Once you add or subtract the top, then you can factor. In this case, we didn't have to factor anything. But here, now it's in factored form. We could cancel that a with one of these a's. And our final answer, 25/8a. What about example 2 here? First, let's look at the bottoms. We want to factor the bottoms completely. So this has a 5. And we've already looked at this LCD, but let's do it with the problem. Factor out of 5, we get k minus 2. This one's already factored. And so our LCD is a combination of all of these factors. They both have a k minus 2, so I'm just going to include one k minus 2 in my LCD. This one has a 5 though, right? So my LCD is 5 times k minus 2. Okay, so now I need to rewrite with a common denominator. Now this one here, I don't need to change because it's already 5 times k minus 2. But this one, what do I need to do? Well, it's missing that 5. So I need to multiply top and bottom by 5. Now, I've transformed it. Now I'm going to use the same common denominator. Can you see that this here is 5 times k minus 2? And now this one is 5 times k minus 2. But now I need to multiply 4 times 5. So now when I combine, I get k squared plus 16, that one doesn't change, minus 4 times 5, which is 20. all over the same denominator, right? So now I can combine my like terms. 16 minus 20 is negative 4. Notice I just left this LCD in factored form. Do not distribute this because we want to see if something will cancel. And so look, k squared minus 4, that's difference of squares, right? So this factors into k plus 2 times k minus 2. Notice, now I can cancel out a common k minus 2. And then what's my answer? K plus 2 over 5. First, I needed to find my LCD. Let's do some more. All right, next example. Let's look to the denominators. They're not the same, so we need to find a common denominator. Now this one's already in factored form, right? Nothing else you could factor there. Now this one, we need to factor it. Two numbers, multiply to 24, add to 11. Now I can look at this one for some clues because maybe this guy will have a factor of y plus 8. How about 8 times 3? Isn't that 24? And when you add them, it's 11, right? So this is y plus 8 times y plus 3. So look at all my factors involved. My LCD is a combination of all of them, right? So my LCD, now they both have a y plus 8. But this one has a y plus 3. So my LCD needs to have a y plus 3 as well. So what does that mean? Well, that means then that I need to multiply, I need to transform this denominator so it's the same as my LCD. This one's already LCD, but this one's missing a y plus 3, right? So I need to multiply top and bottom times y plus 3. And I've done it here. 7 times y plus 3. There it is. I haven't distributed yet, but I wanted to show you that I am combining the tops only, right? Well, 7 times y plus 3 plus 35 all over my LCD, right? Now they both have that common denominator. Now when you distribute this, you get 7y plus 21 plus 35. Now this doesn't change, so I didn't write it down for you, but here I can combine my numbers, right? 21 plus 35, what is that, 56? So we have 7y plus 56, and again, I just didn't write it down because it doesn't change. And now I need to factor out a 7. They have a 7 in common, so I get 7 times y plus 8. Now I just wrote my LCD here. Okay, now they have a common factor of y plus 8. Now I can cancel that. And so what's left? 7 over y plus 3. That's my final answer. Let's talk about the exclusions real quick. What can y not equal? Because, well, with this example, we have variables in the denominator, and we could have been talking about this for all of the problems. The exclusions go back to the original, okay? So here, y can't equal negative 8 because there's a y plus 8 in that denominator. And here, we need to factor it for us to really truly see what y can't equal. Here, y can't equal negative 8, so we already have that one covered. But here, y can't equal negative 3. So there's two excluded values for y, and you don't need to write these for these problems, but you do still need to consider this because, you're going to have to write the domain, and when you start solving these problems, you're going to have to throw out extraneous solutions, so it's something good to consider. How about this last problem? Okay, let's see here. We're adding two rational expressions. Notice they do not have common denominators. So we need to get an LCD. So I'm going to factor this. It has a 4 in common. So what is that? P minus 5. And then I need to factor this. Two numbers that multiply to positive 15, add to negative 8. Okay? Well, they both have to be negative, right? For it to multiply to a positive 15 and add to negative 8. How about 5 and 3? Yep. So, what's our LCD? Well, let's see. They both have a P minus 5, so I need to include one P minus 5. This one has a 4, so I need a 4 in my LCD. This one has a P minus 3, so I need to include a P minus 3. So this whole expression here is my LCD. It's 3 factors. This thing times that thing times that thing. Now we need to transform our fractions, right? So we have common denominators. What's this one missing from the LCD? Well, it's missing that p minus 3. So we need to multiply the bottom by p minus 3. We also need to multiply the top times p minus 3. Okay, this one's good. What's this one missing? Looks like it's missing the 4, which means we need to multiply the bottom by 4 and the top by 4. So luckily we don't really need to like change anything on the bottom. We just need to know that our new fraction, when we combine it, will have this LCD. And so I've written my LCD here. Now I have 2 times p minus 3 plus, right, plus 4 times p minus 6. Now you'll need to distribute these, so take your time, make sure you're paying attention. You don't have to show as much work as me, but you know, I need you to show me work. When I distribute this, I get 2p minus 6. Distribute this, 4p minus 24. Now, notice, I can't factor anything yet, so you don't want to factor this yet. You have to combine. You have to distribute, you have to add or subtract. But don't mess with the denominator because it's already in factored form. And so I'm just gonna like mess around with the top, right? I need to simplify my top of the fraction and then factor. The bottom doesn't change though. So here I've got some like terms. 2p plus 4p is 6p. Combine these, you get negative 30. Looks like they have a 6 in common. I can factor out a 6, and I get 6 times p minus 5. Now this is when I bring my denominator down so that I can see that they have a common factor of p minus 5. I can cancel that. Looks like 2 goes into both of these. So these reduce to 3 and 2. Final answer? Well, it's just 3 left. So 3 over 2 times p minus 3. You don't need to distribute this. Here's your final answer. All right?